Hey guys, Jay Spark from Triumph Turing here, going through our algebra task sheet. Going to show you some of the solutions to the questions that you will have downloaded. So a couple of key things to remember when taking on algebra questions, those solving for x or any other pronumeral. Two things. Number one, your outcome is you're looking for x equals. So everything that we do is trying to move further and further toward getting x on its own and having a final answer of x equals something. So the value of x that makes an equation like this true, which as a lot of you can probably look at, you can see that x is going to equal 3. But how do we prove that mathematically? That's what I'm going to show you in this video. So the other key thing to remember when doing these equations is this equals sign. Now, a lot of people sort of overlook this equal sign, and what's not realized is that it's almost telling us, number one, it's telling us that everything on the left is equal to everything on the right, which is to say that this is a seesaw of sorts where everything on the left is balanced with everything on the right. So when we're taking on equations like this, what we're actually doing is adding things to each side or taking things away from both sides so that they match up. Now, as you can see here, my ultimate outcome is x equals. What's in the way of that at the moment is this positive 4. So plus 4 indicates that this is positive 4, and that is in the way of my x being on its own on the left over here. How I combat that is by running out my x plus 4, and the opposite of a plus 4, or how I get rid of plus 4, is by minusing 4. So its opposite is minus 4, and to keep my seesaw in balance, because as it stands like this, if I bring my 7 down as well, I'm actually left with an imbalance. I've added in a minus 4 on my left, haven't done anything on the right. We're out of balance by minus 4. So I also have to add my minus 4 to the right-hand side, so on both sides here. On the left, when we simplify down to the next line, plus 4 and minus 4 actually cancel each other out. And 7 minus 4 is going to leave us with 3. So to take on a similar question over here at question number 2, x minus 7 equals 2. So same process as before. This minus 7 is in the way of x being on its own, so I need to get rid of it. What's the opposite of minus 7? Plus 7. So I end up with x minus 7 plus 7 equals 2 plus 7. The reason, again, once I've added in this plus 7 on the right hand side is that I've thrown it on the left hand side to get rid of this minus 7, which means that I also need to add it on the right hand side to keep that little seesaw in balance. On the left, x minus 7 plus 7, these two are going to cancel each other out, leave me with just x on the left hand side, and 2 plus 7 is 9. Now we can double check these questions by putting the value for x back into the original equation. So 9 minus 7 is 2, which means we know we have the right answer. Same as back over here, x equals 3. Well, 3 plus 4 equals 7. That also holds true. So that's how we can double check along the way. On to the next question, 4x equals 12. Now, this 4 is the new number that's in my way of having x on its own. What's the 4 doing to the x? It's timesing. How am I going to get rid of this 4 times? Well, I'm going to complete its opposite. I'm going to divide by 4. So I take this 4x down, divide by 4, and once again, whatever I do on the left, I have to do on the right. These 4s cancel each other out, which means I'm just left with x, and 12 divided by 4 is equal to 3. The last question of these simple 4 is x divided by 3. So once again, divide by 3 is what's in the way of having x on its own. How do I get rid of that divide by 3? I bring in its opposite. X divided by 3 times 3. Once again, timesing both sides by 3. I've added in the times by 3 over on the left-hand side because these two are going to cancel each other out. But because I've added this in, I've got to keep my seesaw balanced. And so I have to times the other side by 3 also, which means that when these two cancel each other out, I'm left with just x. And 5 times 3 leaves me with 15. Now, we've all seen Shrek. And in Shrek, Donkey and Shrek are talking about how onions and ogres are very similar because they have layers. Now, that's how I like to think of these algebra questions. When we have multiple numbers in our way of getting x on its own, we have to peel it apart like an onion or an ogre. So we take the outermost layer first, being the number that is furthest from x, and we strip that away and keep stripping away until we only have x left on its own. So in this case, divide by 5 is, well, dividing this 2x, which means it is furthest away. So we end up with 2x divided by 5. To get rid of this divide by 5, I'm going to times by 5. And because I've done it on the left, I also do it on the right. These are going to cancel each other out, which leaves me with 2x, and 8 times 5 is 40. Now I can tackle this 2. It's all that's left in the way of me having x on its own. So the 2 is multiplying the x, which means that its opposite is dividing. Now I've divided the left-hand side by 2, I also need to divide the right-hand side by 2. These 2's cancel each other out. I'm left with x equals 40 divided by 2, which is 20. This question over here is similar in that there's 2 numbers that we need to get rid of, same as over on the left-hand side here. Except this time we have a plus in the mix. So we have 3x plus 5. Now the number that is most sort of obviously furthest away from the x, so our outer layer, is this plus 5. To get rid of plus 5, I'm going to minus 5. And because whatever I do to the left, I have to do to the right to keep the seesaw in balance, I'm going to also minus 5 from the right. When we simplify this, 3x equals 14 minus 5 is 9. Now I'm going to take on the 3. 3 is timesing by the x, so we're multiplying the x by 3, which means I bring his opposite. And once again, what I do to the left, I have to do to the right. These 3's cancel each other out. I'm left with x equals 9 divided by 3 is 3. Lastly, a slightly more tricky one. I've got x minus 5 over 2 equals 3. Now over here in my onion, my outermost layer is this divide by 2 because it's dividing both the x and there's x minus 5 all divided by 2. So that 2 is my outermost layer, which means I take him on first. How I do that? Times the whole thing by 2. Whatever I do to the left, I have to do to the right. These cancel out. X minus 5 equals 3 times 2, which is 6. Now I just have this minus 5 to get rid of. The opposite of minus 5 is plus 5. Whatever I do to the left, I have to do to the right. These two are going to cancel each other out, and I'm left with x equals 11. Now this last question is has a couple of other components to it. We've got a negative in the mix there. We've got some other funky stuff going on. We've got a minus 2 as an answer instead of a positive number. So this one's going to be a bit harder. Now, furthest from the x in my onion over here is this 4. Now, don't be fooled by that minus sign there. This is a positive 4. There's a little invisible plus in front of it. And so we're going to treat it as such. We have 4 minus 3x. I'm trying to get rid of this positive 4, so I'm going to minus 4 from the left-hand side. Whatever I do to the left-hand side, I have to do to the right-hand side. Over on the left, this 4 and minus 4 are going to cancel each other out, leaving me with negative 3x equal to, now minus 2 minus 4 is equal to negative 6. Now I can get rid of this minus 3 in one big go. This minus 3 is actually timesing by the x, so x times negative 3, which means I can get rid of this minus 3 by dividing by minus 3, or reduce it to 1, I should say. Whatever I do to the left, I have to do to the right. So I have x equals negative 6 over negative 3. Now, negative 6 over negative 3 is equal to 2. So there you have it. There's all the solutions for our algebra sheet.